You are welcome back in Sanjeevanee Mahavidyalaya Chapoli, Department of Physics. This lecture number 4 is for B.Sc first year physics students. Paper number 1, semester number 1, Mechanics, Properties of Matter. Unit number 3, Viscosity. In last lecture we have seen about the applications of viscous fluids. Now we continue the remaining portion of this unit number 3, Viscosity. Here we shall see the different types of flows of fluid. In last lecture we have seen pumping operation of the fluid in making the blend fuel. Viscosity we have to consider. Now we shall see the flow of liquid. Laminar flow. This laminar flow is also known as what? Streamline flow. From this streamline name, it is clear that such a layers are here. You see this layer. These layers are not mixing with each other. They are propagating individually in a straight line. Here, because of obstacle, this layer is coming like this one is like this. I mean, there is no disruption between the different layers of the flow of liquid. Such a flow is said to be laminar flow or streamline flow, and exactly opposite to this is said to be turbulent flow. It is said to be roughly turbulent. I'll give you different examples of laminar and turbulent flow. So at present you remember no mixing between layers. It occurs when the fluid flows in parallel layers with no distortion between the adjacent layers. You see this figure. There is also no disturbance. So this flow is also streamlined. Though there is a curve, but there is no disturbance in the neighboring layers of the liquid or fluid. This flow is also said to be what? Streamlined. Here, streamlines for fluid passing an obstacle. Streamline velocity of a particle is tangent to the streamline. So take any point here, and if we consider this is a circle, then if we draw tangent to this point, tangent to the circle at this point, then this tangent shows the direction of velocity or velocity of a particle. Velocity of a particle for the laminar flow of a non-viscous liquid is like this. Now laminar flow is nothing but in fluids, scientific study of properties of moving fluids. Laminar flow is a flow regime characterized by high momentum diffusion, low momentum convection, pressure and velocity independent from time. Momentum diffusion refers to the spread of momentum between particles of substances, usually in liquids. Laminar flow, third condition is fluid moves slowly. Viscosity is relatively high. Flow channel is relatively small. Actually, if we think about the biological ways, then blood flow through capillaries is laminar flow, as it satisfies three conditions. Most type of fluid flow is turbulent. There is poor transfer of heat in case of turbulent. I will show you one figure so that you will come to know See, the person is smoking. This smoker, actually smoking is very injurious to health. This example is actually not suitable here if we consider the addiction of cigarette. So first of all, I request you that one should be free from such a smoking habits. Smoking is injurious to health. So let it be now. Here you see the smoker is going to smoke and he is keeping his hand steady and smoke is coming from his lighted cigarette. This flow from this to this, there is no mixing of layers. Such type of flow of fluid is, yes, such type of flow of smoke from this position to this position shown by this bracket, from this to this, shows the streamline flow, or we say laminar flow. Here velocity of the smoke is maximum and this velocity is said to be critical velocity. The maximum flow of fluid with the maximum velocity in a laminar flow where the turbulent flow begins is called as critical velocity. I mean, beyond critical velocity, turbulent flow starts. So from this to this, what happens? There is a flow of smoke and this flow of smoke is said to be what? Turbulent flow. Got it? Why we say this flow is a turbulent flow? Because layers slide over each other. They mix with each other. They overlap with each other, we can say. So laminar flow over a flat and horizontal surface can be pictured as consisting of parallel and thin layers. And layers slide over each other, thus the name streamline or smooth. The paths are regular and there are no fluctuations in case of laminar flow. There is no fluctuation. Now you see one more slide I will show you. Turbulent flow usually occurs when the liquid is moving fast. The flow is chaotic and there are irregular fluctuations. Irregular fluctuations are there. And they include low momentum diffusion, high momentum diffusion, rapid variation of pressure and velocity of the fluid. Good way to transfer thermal energy. Some thermal energy is transferred in this flow, that is turbulent flow. So in this way, laminar and turbulent flows can be differentiated. The speed of the fluid at a point is continuously undergoing changes in both magnitude as well as direction. Here you see speed of the layers, sometimes decreasing, sometimes increasing. Their direction is not uniform, not in one and the same. Their direction is also what? Moving, changing. So the speed of the fluid at a point continuously changing in magnitude as well as direction, means it has velocity. Its velocity is going to change. Turbulent mixing between two layers takes place, as shown in this figure. Now some examples of turbulence we see. Oceanic and atmospheric layers and ocean currents. Ocean currents, ocean current you might have seen, you might have observed. External flow of air, water over vehicles such as cars, ships, submarines. In racing cars, for example, leading car causes understeer tear at fast corners. Turbulence during airplanes flight. Most of the terrestrial atmospheric circulations, flow of most liquids through pipes is the turbulence flow. These are the various examples of. So in this way, we have seen various examples of turbulence. Now, we discuss one more concept. Actually, it is not in our syllabus, but for the better understanding of the concept of viscosity, I'll discuss with you about another concept, that is Reynolds number. What is Reynolds number? A dimensionless number in fluid mechanics, dynamic pressure, shearing stress. Thus, it qualifies the relative importance of these two types of forces for given flow conditions. Arises when performing analysis of fluid dynamics, can be used to determine dynamic simulative such a cases. Concept used in the testing of models, for example, testing of miniature airplanes, submarines, etc. Now let us overall see dynamic pressure plus shearing stress. Dynamic pressure, the pressure of a fluid which results from its motion. Q is equal to half PV square. Fluid density, fluid velocity. Shearing stress measure the force of friction from a liquid acting on a body in the path of the fluid. This is nothing but DSW. Then Reynolds number, flow in a pipe or liquid. P is the density of the liquid, V is the mean fluid velocity, diameter, Q stands for volumetric flow. Then Reynolds number is nothing but rho Vd upon mu, where mu is the dynamic viscosity of the fluid, V is the kinematic velocity of the fluid, and A is the pipe. I mean, if suppose pipe is circular, its cross-sectional area. Reynolds number can be used to determine if a flow is laminar, transient, or turbulent. Transient or turbulent. Laminar when Reynolds number is less than 2300, laminar flow. Turbulent flow when it is greater than 4000, and transient flow whenever it is between 2300 to 400. Transient flow is the flow between laminar and turbulent flow of the fluid. So these are the biological examples given. So in this way, in the same figure, I will show you. This is the range of the flow of fluid. From this to this is streamline. From this to this we say transient, and from this to this is nothing but what? Turbulent flow. In this way, we can say that the laminar flow, turbulent flow, and the transient flow depends upon the Reynolds number. So remaining information we shall see in the next lecture, number 5. The remaining we shall see carefully in next lecture. Now let us stop here. Thank you. Wish you good luck.